Okay, now in this example of two trig functions, the sine and the cosine curve, we're asked to find the area of one region in here. Alright? I'm trying to find the area of one of these regions trapped by the sine and cosine curve. So just for simplicity's sake, we'll say that f of x is equal to sine x and g of x is equal to cosine x. Okay, so there's the sine x, this is f, this is f here, this is g here. Okay, now find the bounds. So we're going to find the bounds where sine x equals cosine x. We're going to find the bounds, and we can see that right here and right here. So it looks like pi over 4 and 5 pi over 4, but we knew that already from our study of trig, getting ready for the AP exam, so we know that. So we're going to integrate. So we're just going to get this area right in here. That's what we're going to get right there, that area. So integrate, okay. So that area is equal to integral from pi over 4 to 5 pi over 4. Now sine x is the top curve here, so it's going to be sine x minus cosine x dx. So that's going to be negative cos x minus sine x evaluated between pi over 4 to 5 pi over 4. So that'll give us negative cos 5 pi over 4 minus sine of 5 pi over 4 minus negative cos pi over 4 minus sine pi over 4, which should give us, correctly, that's going to be radical 2 over 2, because cos in the second quadrant is negative, but then it's negative again, so it's negative. So it's going to be positive radical 2 over 2 plus positive radical 2 over 2, and then radical 2 over 2 again, both positive. This is going to give us radical 2. That's going to give us another radical 2. So this is going to give us 2 radical 2. Onward to down to example 5. Now we have this horizontal section that we're going to try to find the area of, indicated by the question mark right there. So we're going to do it with respect to, find the integral with respect to y. So we have area is equal to negative 2 to 1. We can see it's from negative 2. But, oh, we have two different sections, so we have to be careful. Okay, we're going from negative 2 all the way to positive 1. Negative 2 to positive 1, we were saying with respect to y. So it's negative 2 y value to positive 1 y value, so keep that in mind. It's not with respect to x like we're normally used to looking at here. So you're going to get 3 minus y squared, which is the top curve, which is the parabola on its side, minus the line going down here. So it's kind of like right minus left almost. Alright, so y plus 1 dy. So it's going to be the integral from negative 2 to 1. Simplify the terms on the inside, 2 minus y squared dy. Then you're going to get that equals, after we integrate, we're going to get 2y minus 1/2 y squared minus 1/3 y cubed, evaluated from negative 2 to 1, which will give us 2 minus 1/2 minus 1/3 minus, put in a negative 1 in there. Well, that was a 1. Now we're putting in a negative 2. We're going to get negative 4 minus 2 plus 8/3. And then if we calculate that out, that'll be common denominator over 6 minus, and over here also 6. I'm trying to get a common denominator between these two fractions so we could simplify it all the way. We're going to get 27 over 6, which should equal 9 over 2. I didn't make any mistakes. That's what it should be. So that's the area trapped by these two curves from kind of like right to left, but we're doing with respect to y dy. Number 6, f of x is defined to be the integral from -1 up to x, a function, so our function's the upper limit. So this is the accumulated process revisited of g of x. So we have an unknown value right there. So we're asked to find f of -5. So part A, find f of -5. Well, f of -5 is going to equal to the integral from -1 to -5. So be careful because we're going this way. -1 to -5, because that's what f of means. So it's the accumulated value from -1 to accumulated area from -1 to 5. So we have some area below, some above. To pay attention to that. Of g of t dt. So we're asked to find f of 5, and f is defined to be the integral from -1 to x of g of t dt. So that's the reason why we're using this integral. So remember, we're going to switch the limits of integration, so our lower limits on the bottom and the higher limits on the top. And we have g of t dt. We have to split that up right at -3. That's where it's going to split up. So the integral from -5 to -3. That's where our quarter circle stops, and I have two triangles right here, just a convenient way to do it, because we can compute this area without just geometrically. So that's going to give us -pi plus 0. So therefore we have f of -5 is equal to -pi. That takes care of part A. Part B asks us to find all the values in the open interval -5 to 4 where f is decreasing. Well, f is defined to be the integral of this function g. So if I want to know where f is decreasing, I take the derivative of both sides, and I get f prime is equal to g of x with the fundamental theorem of calculus. So therefore we know that f prime x is really equal to g of x. So we're really looking to see where g of x is negative, essentially. So that's where f prime x is less than 0. So that's on -2 less than x less than 1, because you can see, so g of t is negative. So that's where f prime x is going to be decreasing. So f of x is decreasing, or f prime x is negative, sorry, decreasing on -2 less than or equal to x less than or equal to 1. He asked for the equation of the tangent line tangent at the graph of f at x equals -1. So the equation of the tangent line. So the equation of the tangent line, so what does that mean? They're actually looking for the point f of -1, which basically means we have the integral from -1 to -1, because that's where it starts from. We know it starts from -1. That's where because that's what g is defined to be initially. So that's the reason why we're starting from -1. So in this case, they're asking about the point f of 1. So it looks like we're going to get a 0 here of g of t dt. And that's going to equal 0, so that means we have the point -1 comma 0. So we know a point that the line goes through, and we should need to find the slope. Well, the slope is going to equal f prime at -1. Well, what's f prime at -1? F prime is going to be, well, f prime is going to be just g, so it's going to be g of -1. And g of -1 is -2. So I have g of -2, so therefore the equation, we could say, is y is equal to -2 times x minus 1. It's the equation of the tangent line at 1 comma 0. So there's a 0 to put in here. That's why there's no y minus y1. It's just y minus 0. Part D. In part D, we're asked to find the minimum value of f on the closed interval from -5 to 4. Well, the minimum value is going to occur, so the minimum value of f, which means that f prime is going to change, f prime or g of x is going to change from negative to positive. So it either occurs at the endpoint or it occurs when f prime or g is going to change from negative to positive. So it's either going to be at -5, 1, or 4. So we evaluate those 3 points right there. So we have x, our 3 values are going to be -5, 1, and 4. And fx, f5 is going to be, we know f of -5 was -pi. We computed that earlier. Now 1, g of 1. So we put in f of 1 earlier, and we found that f of 1 was -2. Okay. And then we try to find f of -4, which is -1/2. So our minimum value is equal to -pi. And how I got these values, f of -5 we got earlier, right up here, and we got that was -pi, so I don't have to do that one again. All right. And also it's because it's the area of this quarter circle. Remember, we're calculating from -1 to -5. So these two triangles knock each other out to the same area, so we're just left with -pi, which is right here, and that's what f of -5 is. So in just in case you want to know, so f of 1 is the area from -1 to 1. So f of 1 to 1, -1 to 1. So if we get this area down in here, we have a triangle, so it's 2 times 2, area base times height divided by 2, so it's going to be 2, right? And it's negative because it's below the x-axis, so that's why that f of 1 is equal to -2. And then 4, so f of 4 would be the integral from -1 to 4. Well, this triangle right here, that's going to be 4 times 1 divided by 2, so that's the area of 2. 4 times 2 is right. And then you have to find, and then from -1 to 1, which we just did, I think, so it's going to be 2 times 2 divided by 2. The area of this triangle is 3. 3 times 1 divided by 2, so that's 3 halves right here. So this area of that triangle is 3 halves. And then from -1 to 1, that's going to be 2 times 2 divided by 2, so that's going to be -2. So that's why we get -1/2. That's why we get -1/2, because it's going to be 3 halves minus 2 to give us -1/2. So we look at the minimums, and we can see that minimum candidates is going to be -pi. Function gives us a density function of cars in a 10-mile line approaching Disney World as they look to enter Magic Kingdom. So we're trying to estimate the number of cars, the total number of cars in the 10-mile stretch. Wow, that's a lot of cars. So this is our f of x that it's given to us, so we would integrate this dx from 0 to 10 in miles. Okay, and if we did that, that'd be approximately, if we calculated it out, it's really messy. I'll just save you a little time here. About the number of cars if you compute that out. Alright, that concludes this first lesson on the area between two curves.